Good evening. My name is Vincent Romero. This is Manuel Monroy. We have Dustin Hess, Marvin Aviles, and Mustafa Diali. We are Team Engineers, and today we're going to talk to you about our major and minor losses across a ramp pump system. Our little overview about our project, we will give you a background explanation of a ramp pump system, the objective of our project, and the scope. We will tell you what we had to determine to obtain our objective. And the methodology, we will show you a brief description of a video of how a ramp pump system works. We'll discuss the video. We will show you our project schedule and the guesstimated cost of our project.
Homestead properties typically require a good source of water delivery. Ponds, streams, and springs are all good source of constant water supply. So how do you transport or deliver from your source of water to your home, garden, or storage tank? Normally you use manual labor to carry buckets of water across distances or power a pump. A ramp pump provides a reliable solution for the transportation of water without the use of electricity, fuel, or manual labor.
The objective of our presentation is to validate the energy losses gained or lost in the system. To do this, we will compare the efficiency of the energy, the volumetric efficiency, and compare that to our experimental values. We'll also demonstrate how a ramp pump operates and demonstrate to you the water hammer effect.
Prior to experimentation, we will assign theoretical values in order to calculate the theoretical efficiency of the system, as well as to determine the major and minor losses of the system due to water flow through the pipe, as well as through bends, sharp turns, valves, and T's. We'll also be determining the overall head of the system, as well as the outflow rate. We'll also be looking for ways to improve the system's overall efficiency. We will begin the ram pump cycle process by initially priming the system. We will close the exit valve and allow water to flow through the system, building up pressure inside the air chamber. We will then press down on the waste valve and prime the system. Go ahead. Here's a video of a ram cycle currently in progress. Water flows through the inlet and out through the now primed system out of the waste valve. Pressure is constantly building up right below the waste valve, and eventually the pressure overcomes the weight of the valve and slams the gate shut. When this happens, the water flows through the next valve, and water begins to build up in the air chamber. The pressure in the air chamber eventually overcomes the static pressure required to push the water up the delivery pipe. Once the pressure in the system begins to lower, the delivery valve slams shut and water again flows through the waste valve in an endless process. This is the water hammer effect that you see happening right now, where the valve is constantly slamming open and closed.
As previously mentioned, ramp pumps utilize potential energy and kinetic energy to drive the water to a higher elevation. Here we see the source of water with potential energy delivering the water through the dry pipe, building kinetic energy to the ramp pump. The ramp pump then adds additional head to the water to deliver the water to a higher destination. Now, as previously mentioned, ramp pumps use the water hammer effect to increase water pressure in a short distance in pipe. The water hammer is indicated in this diagram here. As water comes into the inlet, and this valve is originally open, water will exit the swing valve. As the velocity increases, the swing valve closes, water slams up against it, and goes through the flow of least resistance. Some of the water goes downstream, some of the water goes back up the dry pipe. Now, by shutting that swing valve, pressure is built up. Now, that pressure is what creates the water hammer effect. Again, that creates a shock throughout the system, causing some of the water to flow back into the dry pipe and some of the water to flow downstream. Some of the water goes up the pressure chamber, but due to the compressed liquid of compressed air, it can't compress it any further, and thus the only way water can flow is downstream. Now, the water hammer effect creates such a shock in the system that the components used to build up the ramp pump need to be strong enough to handle the shock forces. Additionally, there's a filter upstream to prevent any debris from entering the valve assembly that can potentially damage the components. Now, with a good design and good workmanship, a ramp pump can operate for over a year without any maintenance necessary.
As shown here, this is a Gantt chart that we made to show our project progress done on the time. We are currently at the process and assembling and the presentation, and we try to deliver our project on time. As the Gantt chart is made, our project is supposed to be on time according to our schedule. And next is the cost. There is also a cost associated with all this assembly. The cost for a ramp pump component are estimated to the range between $125 and $250. $125 is one we use a PVC valve, and $250 is a galvanized steel, which costs higher in the market. There is also a cost associated with the land survey. As we know, we have to use a land survey to know how is our gravity to